Lesson 3. Function Models. Function models describe the intention of a system. They do this by describing some beginning state of a system and then the desired objective state of the system after the function occurs. Furthermore, function models describe one or more external stimuli which act on the system to help accomplish the function. In this section, we will consider the naming conventions for functions, the intended use of the system, beginning and objective states, 3 different kinds of functions, and using functions to describe interactions between the system and things external to the system. SBF models are organized primarily by function, which is the intended consequence of a system. Functions are typically of the form subject, verb, noun, optional conditions, where optional conditions are usually direct objects or prepositional phrases. Example functions are: for a piston crankshaft arrangement to convert linear motion to rotational motion, for a flashlight to create light, for a lotus leaf to clean self, for a sponge to filter nutrients from water. Note, we use the word intention in our definition of function. For man-made systems, there is typically some intention for the system, which we call its primary function. A system, however, could be used for some other purpose. For example, my coffee cup is intended to be used as a device to hold hot liquid. That is its primary function. It is conceivable that I could use it to break a window or to hold down my napkin. But those are not the intended functions of the coffee cup. SBF arranges models based on the intended use of a system. A definition of state is the set of values of the properties of one or more of the components of a system at a single point in time. For instance, state 1 of the flashlight switch might be mode equals off, while state 2 might be mode equals on. Or, state of the light bulb in the system might be state A, lumens equals 0 foot candles, state B, lumens equals 30 foot candles. We can name a state anything we like. What is important is the values of the properties in a state. If you think about this, you'll realize any real-world mechanical system can have an infinite number of possible states. We can choose any one of an infinite number of moments to take our picture. For the moment, let's not worry about this. We'll talk more about why certain states are selected later. For now, we just want to understand the concept. A function usually specifies the beginning state of a system and then some objective state of the system. The function of the light bulb circuit describes the changes in the system from the beginning state to the objective state. The function of the flashlight, create light, describes the change from a state with no light to a state with light. Note, the notion of objective state may be more subtle than in the case of the flashlight. Take the case of an air conditioner regulating the temperature in a room. In this case, the temperature may rise and then return to the original temperature. In this case, the objective state could be the same as the beginning state. Alternatively, there could be no change at all. Take the case of a safe whose function is to prevent access. In this case, some portal, such as the door to the safe, is blocked by some locking mechanism. Once again, the beginning state and the end states will be the same, but in this case, there is no change in the state of the safe at all, at least for the function prevent access. We give these 3 kinds of functions special names. The first we call an accomplishment function. An accomplishment function, by definition, creates a new desired state. Therefore, for accomplishment functions, the beginning and objective states are different. The light bulb circuit is an example of an accomplishment function. A function can also ensure something is always returned to its original state. For instance, the function of an air conditioner is to return a room to its original set temperature. This is a maintenance function. In this case, The beginning and objective states of the system described by the function should be the same, but intervening states change. The temperature of the room, for instance, may go up and down, but eventually it returns to its original state. We can also have functions that prevent a state from being achieved. The purpose of a locked safe, for example, is to prevent the door from ever being in an open state while it is locked. This is a preventative function. Like maintenance, the beginning and objective states of the system described by the function should be the same, but intervening states should not change. Thus, the portal state, in other words, the state of the door to the safe, is blocked in the beginning state, blocked in the end state, and should remain blocked through all intervening states, such as during a state where the safe is being hit with a hammer. Functions describe a change in the internal state of the system. However, functions also specify the way in which the system interacts with the external world. In particular, functions describe the external stimuli that act upon the system in some way that causes it to change state. In the three examples provided previously, we see that the function createLight in this example requires an external force to activate the switch. In the case of regulating temperature in the room, some heat source external to the room may be heating it up. In the case of preventing access to the safe, some external force, a sledgehammer for instance, could be working to unblock the safe door by hitting it. SBF models are organized by functions which are described by subject, verb, object phrases. Function models describe the intended use or purpose of a system. They do this by providing a detailed description of a system prior to the function executing, and then describing the conditions after the function has carried out its intended use. A state is a snapshot in time of the system. The function model first describes the beginning state of a system, which is the set of initial conditions of the system. Next, the function model describes the desired objective state of the system after the function has occurred. Both the beginning and objective states are described in terms of the properties, values, and connections we saw in the structure model. Finally, function models describe one or more external stimuli which act on the system from outside of the system to help accomplish the function. Think of the function as why the system exists.